All right, guys, so this lesson is over the distributive property. We're going to start with some important vocab, okay? We're going to use these words quite a bit in this course. One of the most common directions I could give you is I could ask you to combine like terms, okay? What are like terms? Like terms are things that have the same variable factors, okay? Terms that both have the letter x as the variable in front of it. And the important thing about like terms is that each variable needs to be raised to the same power. Okay, so one of the most common directions I'll give you, like I said, is something like combine like terms. All that means is squeeze it together as much as possible. Okay, when I want something in simplest form, that means a bunch of different things, but that means number one, that there's no common factors, no like terms, and no parentheses exist. It's in that squeezed together version as much as possible. Okay, a lot of you guys are going to have issues with this. You might think it's a little bit difficult at first, but there is a learning curve, and you guys will get it eventually on what it means to put something in the simplest form possible. Okay, two extra vocab words that I really need you to know. There will be a vocab portion on the test, and here's two key important words that you need to know the difference between. Okay, a coefficient is the numerical factor of a term. Okay, here's an example of a coefficient. If I give you something like 3x, okay, the coefficient for this term is the number 3. Okay, it's the number in front of the variable. Okay, but in comparison, we could also have a constant in an algebraic expression. Okay, a constant is just a numerical term by itself. Okay, so if I give you the algebraic expression something like 3x plus 7, a constant is a number that is just sitting by itself with no variables next to it. In this case, the constant would be this number 7. The constant is all by itself. It doesn't have a variable attached to it. It's the number 7. Okay, going on. A lot of you guys are familiar with the distributive property. Okay, we've done this principle before in 7th and 8th grade math. What we're going to work on right now is making sure that we're carrying over any term to whatever's inside the parentheses that's next to it. Okay, so for example, we're looking at 3 times the quantity 2 plus 5. You guys should remember this from last year, but what we're doing is we're doing multiplication over and over again. So we see 3 times all of this stuff in the parentheses. And you guys might remember drawing these arrows before in previous classes. What we have to do when we're doing this question is we have to carry this 3 both to the 2 and to the positive 5. So 2 is being multiplied by 3, as well as the 5 is also being multiplied by 3. You guys remember drawing these arrows over and over again. For here, we're seeing 4 times the quantity 9 minus 7. If we wanted to do distributive property using the question, what we do is we take 4 times 9 and also 4 times negative 7. Most important thing here is we got to remember that we have to account for the sign in front of each of those terms inside the parentheses. Okay, we're going to skip this word problem. Let's just start doing some examples. Let's pick letter A to start. Okay, probably the simplest example on here. So here's what we see. It says use the distributive property to rewrite each expression. So I see 3 times all of this stuff in the parentheses, x plus 8. If I want to simplify this question, what I have to do is I have to carry this 3 to every single term I see inside of those parentheses. This 3 has to go with the x, and that 3 also has to go with the positive 8. Okay, after you do that, you just have to rewrite it as a multiplication question. Okay, so the first piece I see here is I see 3 times x. Okay, is there any way I could write that any cleaner? Not really. Those aren't really like squeezable terms together, so we just leave it as 3x. Okay, the next thing I have to do is I have to take this 3 and I have to also multiply it with this positive 8, which would be plus 3 times 8. And we know that 3 times 8 can be squished together into one term. It's the exact same thing as 24. I could rewrite this as 3x plus 24. Multiply the 3 with both of the terms inside the parentheses. Okay, let's look at example B. So I have 5b minus 4, and all of this is being multiplied by negative 7. Okay, when we're dealing with negative numbers, we have to be a little bit more careful. This negative 7 is going to carry to the 5b as well as the negative 4. Okay, the first thing I see here is I want to take 5b and multiply it with negative 7. So I see two numbers. I see a 5 and I see a negative 7. Let's multiply those two numbers together. 5 times negative 7 is going to be negative 35. Okay, when I multiply the 5 and the negative 7 together, I get negative 35, but I can't forget about my b. That b is not going anywhere, so I'll have negative 35b for my first term. Okay, the second thing I see is remember, I got to account for that sign in front of the second number, and it's negative 4. The next thing I see negative 7 times negative 4. Off to the side here, I've got negative 7 times negative 4. Remember, if we multiply a negative with a negative, what does it become? It becomes a positive. Negative 7 times negative 4 is going to be positive 28. If I have positive 28, it becomes a plus 28. That's the distributed version. We'll do one more example here. Let's jump to letter E. Here I just see a negative times negative x plus 31. Okay, whenever you see just a negative sign, it's basically the same thing as multiplying by negative 1. I got to distribute this negative 1 to both the negative x and to the positive 31. So I'll have negative 1 times negative x. Just like before, if I have a negative 1 times a negative, negative times a negative becomes a positive, this would just become plain old positive x. X is my first term, and then I have negative 1 times positive 31, negative 1 times positive 31. Okay, 1 negative, 1 positive, that means it becomes negative. It's going to become minus 31 down here. That's my distributed version. Okay, nothing else I can do to squeeze those terms together. It's in simplest form. Okay, we'll jump down to example 4 over here. It says combine like terms and simplify the expression. Okay, when you see combine like terms and simplify, that means I want you to squeeze this thing together as much as possible. Okay, so for the first example here, I give you 17a plus 21a. And the question you have to ask yourself is, are these like terms? Can I squeeze these together? Okay, in order for terms to be like, you need two different things. You need them to have the same variable. In this case, they do. They both have the letter a attached to them, and they both need to be raised to the same exponent. In this case, they are. You can imagine a little imaginary 1 above both these things. Okay, both these are being raised to the first power. It's 17a plus 21a. Okay, because these guys have the same variable and are raised to the same power, we can squeeze these two terms together. So what does that mean? I want to start with 17a and I want to add 21a. I'm starting with 17 and I'm adding another 21. Okay, it's pretty simple. Just take 17 plus 21 and you should get something like 38. Okay, if I start with 17 A's and I add another 21 A's, I should be left with 38 A's as my final answer. Okay, in comparison, here's a second one. I'll give you 12b squared minus 8b squared plus 6b. Okay, so the tricky part about this one is not all of these terms are combinable. In order to squeeze terms together, you need terms to have the same variable. In this case, all three do, but they also need to be raised to the same exponent. Okay, so here my first two terms are being raised to the second power, but that last term is not being raised to the second power. So the only two terms that are combinable are this guy and this guy. If I start with 12b squared and I take away 8b squareds, how many b squareds am I left with? I'm left with 4b squareds. Okay. But then at the end, I see this plus 6b. Is that combinable with b squared? No, it's not. It's got a different exponent, so I just leave it as is at as the last term. Okay, nothing more can squeeze together. That is in simplest form. Okay, we'll do one final example. It says you want to write an algebraic expression for the verbal expression given above. Okay, I'm giving you an expression in words, and I want you to write it using algebraic symbols. Okay, lots of words here, but let's break it down into its individual pieces. Okay, it says 6 times the sum of x and y. So the first number I see here is 6, and then the operation I see is multiplication. times the sum of x and y. When I see this word sum, what am I thinking? I'm thinking addition, right? And what are the two things I'm adding together? I see x and y. Okay, so let's just start with that first part. Okay, I'm starting with the number 6. And I'm going to multiply something by 6. And what am I multiplying by 6? I'm multiplying the sum of x and y. Okay, this entire thing in here is what I want to multiply by 6. Now, how do I write that? Because I want to multiply this entire expression by 6, I need parentheses. So what I'll have here is I'll have in my parentheses, because it's sum, it's addition, x plus y. Okay, that is the first part of this long expression. Then the second thing I see is whatever this thing is, it's going to be increased by 4 times the difference of 5x and y. Okay, the key word here that I need you to recognize is the word difference. Whenever you see the word difference, I want you to think subtraction. Okay, so let's break it down to the pieces. The first thing we see is whatever this thing is over here, it's going to be increased by. Increased by is definitely going to be, what operation is going to be? Addition. Okay, it's going to be increased by 4 times the difference of 5x and y. Do you see this number 4 and you see the word times? So that means we're going to take 4 and multiply it by something. What are we multiplying 4 by? It's the difference of 5x and y. Okay, difference means subtraction. We're multiplying 4 by this entire thing over here. Okay, so what I'll need is I'll need some parentheses, and I want to write the difference of 5x and y. 5x, difference means subtraction, subtraction, y. Okay, that is the algebraic expression for that big, long phrase in bold above. And the next thing I see is I want you to simplify the expression. Okay, all that means is distribute it and clean it up as much as possible. Okay, so I'll use a different color ink here just so we're on the same page. Let's use maybe this green. Okay, so what I want to do is I want to ultimately distribute to make sure that it's in simplest form. So what am I going to do? I see the 6 and I see the x plus y. I got to distribute the 6 to both terms. Uh-oh. Let's try this again. The 6 has to distribute to both the x and the y. I'll have 6 times x, which is just 6x, plus 6 times y, which is just 6y. Okay, I've cleaned up the first part of it. The second thing I see is I see positive 4. Make sure you're attaching that positive symbol to when I distribute. I'll see positive 4 times positive 5x. 4 times 5x is plus 4 times 5 is 20, 20x. And the next thing I see is positive 4 times negative y. What that becomes is minus 4y. Okay, I've cleaned up the first and the second part of my algebraic expression. Now let's see if we can combine together any terms. I see some x's over here and some x's over here. I can really squeeze those together. If I start with 6x and I add another 20x, I'll be left with 26x. And if I start with 6y's and then I take away 4y's, 6 minus 4 is equal to 2, I'll be left with 2 more y's. And that is in simplest form.